Hi everyone. So we I will teach you about the timer interrupt. So timer interrupt. So you can use the source code from the previous lecture from the external interrupt for you can use the same circuit from the external interrupt, okay, for the timer interrupt. Okay, so that means, okay, I want teach you about the circuit. Okay, if you want to create a circuit, you can go back to the previous video, that is the external interrupt. Okay, so what is the timer interrupt? Okay, from the previous lecture, previous practice, I show you about the external interrupt. So the external interrupt is the interrupt waiting it the external interrupt from the push button or from the external signal, like this. Okay, signal connect to the pin number 3, but for the timer interrupt is different. So when we use a timer interrupt, the interrupt signal will be generated from inside the microcontroller. Okay, so actually inside the microcontroller we have the module. Okay, we have the module called timer. Okay, timer is a module to generate a clock. Okay, it will provide you a clock. For the example, when you use the analog right, okay, like this, analog right, okay, to create, you use analog right to create the PWM signal, right? Okay, when you create a PWM signal, it will call the timer. Okay, the timer, we call the timer module. If you call the timer module to create the clock for PWM. Okay, because every signal will have the clock, we have the timer base, we have the time base. Because for this one you can change the frequency, right? So when you change the frequency, it means you can change the clock. Okay, something like that. And timer interrupt is also the same. Okay, we can create the internal clock, internal timer inside the Arduino to trick. We will create the first one. We will create a timer to I can say trick the ISR. Okay, it's different from the previous one because we trick from the external input to trick the ISR. Okay, it's different. It's different. Okay, right now we will use the internal timer to trigger the interrupt service routine. Okay, it's called interrupt service routine. Okay, it's called interrupt service routine. So this I will demonstrate you this one. First, you have to create the internal timer. Okay, I start from this to do. Okay, firstly you have to disconnect the interrupt, okay, to like disable or interrupt. Like okay, and then this one reset first. This one we call timer register. Okay, we have to reset the timer register before config. So and then we try to like assign the timer tcn t1 equal. I have to create some variable called timer1 counter for counting the timer. Okay, and then assign this one timer1 counter. Okay, as maybe 1. Okay, let's start from 1 and then assign this one to this one we call TNT. Okay, timer counter register. Okay, and then we have to assign another one. You can follow my program. Okay, set the P scale. Okay, I will tell you later. Okay, right now you just follow me. And the last one. Okay, I will try to compile first to check my syntax. Okay, okay, it's correct. So I start from this. Try to reset the parameter that can affect the timer. Okay, and the interrupt. So I start from no interrupt first. Try to disable the interrupt. Okay, using no interrupted no interrupt function. And then this one I try to reset the timer register. And then we assign this one timer1 counter equal to 1. Okay, and I also assign this one to the timer counter register. Okay, so what is the parameter? Okay, so I will start from this. So actually in our microcontroller we have 16, right? Okay, this one we call the oscillator. We have 16 megahertz. Okay, and then okay, we have a MCU. We call MCU speed. Frequency is 16 megahertz. Okay, and then we have a P scale. P scale CS12 is 256. Why we have to put the P scale? Because it's too fast. Okay, it's too fast because 16 megahertz is very fast. That's why we try to put the P scale. Okay, actually we have many P scale. You can search from the I think you can search from the internet about that, about the P scale. So for the example, I will try. The timer P scale. Okay, I got this. Okay, here. CS12 here. Okay, the CS12 is mean the clock, the main clock divided by 256. Okay, so if you want the timer, if you want to increase the speed of the timer, you can change from the CS12 to CS11, CS10. Okay, it's up to you. Okay, but I will introduce you with 256. Okay, what does this mean? If the MCU frequency is the 16 megahertz, right? And then you put the P scale. The timer frequency will be 16. Oh, sorry. 16 megahertz divided by P scale. Okay, equal can you hear me? Okay, put the calculator first. Divided by it will be hertz. Okay, it will be 62,500 hertz. Okay, that is the timer frequency. It's still very fast. Okay, because if you want just 1 second, 1 hertz, how can you do that? Okay, and then you have this one we call the timer. This one we call the timer counter. We call the timer counter register. This one we call the timer counter register. So the maximum value is okay, this is a maximum value. Okay, so it means you can like you can calculate if you put TCN T1 equal this one, the frequency will be hertz. But if you put equal one, is around hertz maybe. Okay, so it means you can calculate TCNT1, okay, from the timer frequency. Okay, that means you can vary the timer. You can vary the frequency for the interrupt. Okay, using this formula. Okay. So it means TCN T1 can be okay, interrupt timer frequency. Okay, you can calculate. You have to know first what is the interrupt frequency that you want for this, and then you can calculate a TCNT for that. Okay, and then I will try to create an interrupt from the timer, because right now you have already finished the timer. Okay, for the interrupt you can okay, I try to create one with the toggle equal not toggle, and don't forget to create the toggle equal 1. Oh, sorry. We can reduce. Okay, I will check the frequency. I think we got something wrong, because the frequency of the output should be 1 second or 1 hertz. Okay, I got this. We should reset our timer. Okay, include 1A and 1B. reset timer, and then try again. Why it show nothing? And I think we forgot something about it. Okay, right now it's okay, but my computer is too slow. Okay, so from the output you can try to change the timer counter register, okay, by change this variable. Okay, this one which I put 1, right? You can use this formula to calculate the new value for the timer counter register. Okay, and then don't forget to put this to always set the timer counter, because TCNT1, this is the timer counter register, right? So it will be changed, its build we change to counter the timer for you. It means when ISR is called, it means when ISR is called, it means the timer is overflow. Okay, the timer is overflow means the clock is finished. Okay, when the timer is overflow, this function will be called, and then you have to reset this register again. Okay, so right now you have like a two loop, right? The first one to toggle the LED pin, and the second one for the interrupt service routine for the timer. Okay, from this you can create like a two for loop. You can use this for loop to control the motor, because when you want to control the motor, right, you need strict the frequency of the loop. That's mean I always use this one for control the motor, control speed, or control the position of the motor, because when you want to calculate the speed, when you want to calculate the differential, you have to divide it by the time, right? But when you use the normal for loop, you cannot control the sampling time of the for loop of this loop, but you can control the sampling time of the interrupt service routine that's triggered by timer. Okay, let's do this.